My name is Simon Wrigley, and I work at FEV Consulting. I'll be sharing a few thoughts based on our recent work on hydrogen transport applications and infrastructure. In case you're not aware, FEV Consulting is now a consulting group attached to the FEV group of engineering service providers. We have around 100 consultants around the world in roughly 40 offices, and we provide primarily business consulting services around topics such as market analysis, technology and cost analysis, market and product strategy, business opportunity assessment, and organizational aspects as well, all very closely linked with the expertise within the FEV group from a technical point of view. So we, at the moment, within FEV Consulting, see really a very strongly growing business in hydrogen applications, both in terms of customer interest, where we see a very rapidly rising level of inquiries for projects in this area, but also in a number of relevant KPIs. Just a few ideas here to provoke some thoughts. We expect 4,000 hydrogen stations to be in operation in Europe by 2030, 6 megatons of clean hydrogen production globally by 2030, 11 times more energy in a gravimetric energy density than a battery electric vehicle, and expected 10 million fuel cell vehicles by 2040 within one of our future scenarios on the road globally, as well as in off-road applications. So really a very strong and exciting market. Of course, different customer groups within this area will have quite different purchase criteria for fuel cell, for any kind of hydrogen powertrain. Thinking about fuel cell customer groups, we can think about early adopters who are looking for new technology. Of course, they will be primarily motivated by the availability of the latest technology. Roadside parkers, individuals who don't have their own private parking spaces, maybe don't have access to electric charging points for convenience, will be very interested in hydrogen cost and availability of recharging, of refueling. And then power users who are flexibly using distances, vehicles for longer distances and high utilization rates, both in the private and commercial vehicle areas, and they will really strongly value the hydrogen range and refueling time benefits. If we compare battery and hydrogen technologies for vehicles, we see that very fundamental cost decreases to take place within the battery arena until 2030, roughly 40% further cost decreases by 2030 versus 2020. But for hydrogen technologies, the cost decreases will continue very strongly beyond 2030. So for example, fuel cell system costs, further 25% at least reduction until 2040 versus 2030. And in the tank systems, also very significant reductions to 2040. The cost drivers for fuel cell vehicles are quite different versus battery electric vehicles, of course, much more influenced by the performance level, where the fuel cell is the primary cost driver versus the battery in a battery electric vehicle. So we see that for vehicles of a longer driving range, hydrogen propulsion systems tend to be more attractive than for batteries, whereas the vice versa is also true. So taking that a little further, here's an example for a small SUV vehicle, 300 kilometers range. We would expect that below distances of 500 kilometers, the battery electric vehicle would tend to be more attractive from a cost point of view of the powertrain, whereas the longer distances beyond 500 kilometers there, the fuel cell variant shows a cost advantage. But then we throw another factor into the mix of charging or refueling time, and here we see a decisive advantage for the fuel cell vehicle versus even the faster charging options available, where this may, of course, tip customers towards fuel cells even at relatively lower driving ranges. So this is of course another factor that gets thrown into the mix depending on the customer priorities. When we come to commercial vehicles, the priorities for customers, of course, tend to be rather different. On the one hand, shown on the right here, the sort of utility factors, such as payload, interoperability with other systems, availability of infrastructure, as well as the local access restrictions that may cause one system or another to be more attractive for a zero-emission truck, for example, as well as the green image. This is a very complex, multidimensional set of criteria. On the other hand, on the financial criteria side, really the main metric here that operators will look to is the total cost of ownership, and to what extent can a hydrogen-powered zero-emission truck compare with either a battery electric powered truck or indeed the incumbent technologies such as diesel or natural gas. So when it comes to total cost of ownership calculation, we frequently carry out analyses of total cost of ownership for comparable vehicle types to enable our customers to get insights into which powertrain types may be most attractive or suitable for specific applications. And here we see quite different results depending on the use case of the vehicle. In this case, we have a 40-ton long-haul truck, and in a baseline scenario for roughly 2030, we see that basically the results show that on as you can see on the right-hand side, the battery electric vehicle is extremely expensive in terms of purchase price versus diesel costs, but also that the operating costs of generally of the fuel cell and hydrogen ICE vehicles are comparable. However, under a more optimistic scenario where we look at hydrogen price below 5 euros per kilogram, suddenly, of course, all vehicles are looking more attractive, but particularly the hydrogen powered vehicles, whether it's the fuel cell or the hydrogen ICE, start to look really quite attractive with payback periods of below 3 years, despite an increased purchase price versus the diesel. You're still going to get a payback within 3 years and continued annual savings beyond that. So of course, then the other factor that is particularly critical there is how is the refueling infrastructure going to be managed, and how can the supply chain provide the green hydrogen that we really need in the longer term? Where can the hydrogen be produced? How to transport it to the point of use, to the fuel pump, and what will the cost be of the different hydrogen production and supply chains that may be involved there. So to help try to answer some of these questions, we've performed some analyses of different scenarios regarding production and supply. And according to our calculations, we see that quite different results depending on the location of the production of the hydrogen. If looking at green hydrogen production, so electrolysis based on renewable sources of electricity, for the first case here, we can see in Germany a primarily wind power driven production facility with the local conditions in Germany ends up being really rather expensive at 3 euros per kilogram of hydrogen produced net. In a Spanish production scenario where we have a mix of wind and photovoltaic power, we get a much more attractive production cost of only 1.8 euros. And then in a North African production location with larger scale still, indeed a further cost reduction to 1.5 euros. Of course, the production itself is only one part of that. The other part, very importantly, is the aspect of how do we transport the hydrogen to the point of use. So here we've looked at a number of supply chain routes. For the German case, at the top on the right, we have a pipeline from, say, a North Sea wind production location to a central German location. And here, with the pipeline and the compression costs and dispensing costs for 700 bar hydrogen at the pump, we see roughly €4.5 per kilogram of hydrogen dispensed. This is net without taxes. For the Spanish production case, we can envisage two supply chains, one involving the shipping of liquid hydrogen via sea and then via road to a dispensing location, and a second case where we take a pipeline across Europe for compressed hydrogen to the dispensing location. And here we see a considerable cost advantage for the liquid hydrogen route, especially if it is dispensed as a liquid in the case of, say, commercial vehicles using liquid hydrogen on board. This largely being due to the extreme, the very significant costs of the compression in the whole process. In the North African case, still further cost advantages, partly through the lower electricity costs, but also indeed due to the advantages of shipping via sea, which is really quite an effective way to ship the hydrogen to the point of use. And here we could envisage costs even as low as €2.7 per kilogram of hydrogen. So under these circumstances, one could envisage, at least on a net basis, hydrogen being below that €5 per kilo price that I mentioned. But of course, this depends very strongly on the level of taxation. And here we are somewhat reliant on governments to set taxation rates to ensure that the hydrogen that is available allows an attractive business case for the users. So one final point I'd just like to make before we finish. We see a range of other factors as also important enablers for the uptake of hydrogen within the transport arena. One is on the left-hand side, the concept of mobile refueling stations, which can be rolled out relatively easily and quickly to diverse locations to provide hydrogen to users in locations where there is not yet a fixed and well-established refueling infrastructure, especially as an early stage where uptake is relatively low and utilization for a full-scale refueling station would not yet be financially attractive. Another aspect that we see as very interesting and a possible future development is the rollout of what we call hydrogen microgrids, where we have a fairly self-contained energy system. Here I show the example of a mining hub where we have production of renewable energy as well as electrolysis of hydrogen, and then supply to local energy needs, all within one site, one self-contained system. This can have certain cost advantages, especially in remote areas in the case of mining. We also see similar opportunities for logistics hubs, as well as potentially the use in municipal transport environments where we have locally generated electricity and local electrolysis of hydrogen, allowing a local ecosystem to establish itself before necessarily a nationwide hydrogen distribution infrastructure is available. So quite a few potentials to encourage growth there, and we certainly look forward to seeing how things develop over the next 10 years and beyond. So thank you very much.
Thanks, Simon. I've got a couple of questions. Firstly, you talk about the diesel versus hydrogen and this getting to €5 a kilogram per kilogram. When do you predict that might happen, or is there a time frame that we're looking at when that might happen?
I think the time frame for this is really very difficult to predict. It's a lot down to the taxation arrangements. It's not down to the willingness of governments to invest in infrastructure, and at the moment, of course, the hydrogen price that is commercially available is not, within Europe at least, does not fully reflect the cost of that supply. So I think there is a need there to coordinate within the energy industry as well as together with the transport industry to ensure that prices are set at a level that encourages uptake in the shorter term.
Yeah, and from that, I mean, over the last couple of days, we've had a lot of discussion around the difference between the grey, blue, and green hydrogen. And do you expect, or from what you've seen looking internationally, that price will be different depending on the type of hydrogen?
I think the indications we see at the moment is that the price tends to be set to a level that ensures an attractive business case for the users, fairly independently of the true cost of generating it. Now, of course, this is an early stage in the market development. In the longer term, there has to be a business case for the supply of the fuel. But at this stage, where everybody is trying to encourage uptake of the technology to get the market running, I think the price will tend to be set at a level that's independent of the source.
And then finally, just to come back on that sort of that financial criteria versus that sort of usability and the utility. I mean, are you seeing? I mean, you know, we've discussed again over the last few days. You know, a lot of hydrogen strategy internationally. Are you seeing those investments sort of going hand in hand, or are you seeing people sort of significantly picking up either maybe, I don't know, investment in infrastructure, or, you know, actually more the financial criteria, or do they have to go hand in hand together, or how are you seeing it play out?
Do you mean regarding the infrastructure? Or
yeah, well, the infrastructure, but also the investment, I suppose, in the technology as well.
Yeah, I mean, of course, we have the problem. It's a sort of chicken and egg problem where the transport industry requires the infrastructure, but the energy companies are unwilling to invest in that until there's a clear demand from the transport industry. So I think this is one of the things that's really holding the development of the whole system back. But yeah, we're certainly seeing a lot of investment in hydrogen from the commercial vehicle sector. The main manufacturers of commercial vehicles are very strongly expecting to move into hydrogen for a significant proportion of their sales fleet by 2030, as indeed they are forced to by the current European commercial vehicle CO2 regulation. And this is one of the few ways in which it is likely to be possible to meet those targets. So we see very strong investment in the commercial vehicle OEMs and supply chain to move in that direction.